Thank you, Max. Yes, thank you for having me here. All right. So broadly what this presentation will cover is ethics, the ethics of AI and machine learning. It's a pretty large topic. And so I'll talk about my experience in it on the next slide. And so probably what I'll focus on, there's two areas I'll focus on, which are in privacy, security, and fairness and justice. And then I'll give you kind of a flavor of like what the other topics that are kind of big in the field right now. And then I'll kind of give examples of like how AI has been harmful in society, and kind of from the academic setting of like research papers that have shown this. And similarly, towards the end, I'll kind of talk about how the ethics of AI and machine learning have played out in industry and some of the pitfalls there. And then kind of forward looking, I'll give you like kind of an overview of like what it means to be able to practice ethics, the ethics of AI and machine learning in industry, kind of beyond like products that you might do, but if you decide to pursue a career in the field, what that looks like. So, all right. Okay, yeah. So just a bit about me. As Max said, I'm a Queen's alumni. So I was in the Bachelor's of Computing program. I specialized in biomedical computing, and I graduated in 2019. I'm originally the class of 2018, but so basically after my third year, so like for QUIP, essentially, I did QUIP, and then so during QUIP, I did 3 internships during QUIP. So like the first one that I did was at IBM Research, and there I was doing deep learning research for like database optimization, and then I worked at a startup, and then I worked at Square as a data science intern, where I was working basically on fraud detection. So like how can we use machine learning algorithms and future engineering to essentially improve fraud detection algorithms in peer-to-peer payment systems. So if you want to send money to your friend or they want to send you money, how can we make sure that that's not being fraudulent, that those transactions aren't fraudulent? And then during my undergrad thesis, I worked on machine learning for healthcare. So broadly, I worked on cancer detection in the PERC lab, which is a lab that does like biomedical engineering at Queen's. And I also worked with doctors, some urologists at the Kingston General Hospital. And then after that, so from 2019 to basically this past June, I was a master's student at the University of Toronto in the Vector Institute, as well as at SickKids. And essentially, this was kind of where I really started to get more into some of the topics I'll discuss on the ethics of AI and machine learning, specifically in privacy and fairness. And so I was broadly working on like privacy, fairness, and cryptography in machine learning for healthcare, and understanding what are the pitfalls of those of wanting very strong privacy, very strong fairness guarantees, and then trying to build algorithms to improve what the current state of the art looks like in those fields. And then now currently, so started a month ago, I'm at MIT for my PhD in the electrical engineering and computer science department, and I just finished an internship at Google Research, working on broadly construed private machine learning this past summer. So that's kind of my background. And so the 2 topics that you'll see that I'll really focus on will be privacy, security, and fairness in machine learning, primarily because those are the 2 areas that I focused on in terms of the ethics of AI and machine learning. But there are many other areas that are incredibly important that I will give like a brief introduction into. And I would very much encourage you to like explore after the presentation as well. So why is ethics important, especially in machine learning, especially broadly like in like the use of algorithms in general as well? So as individuals, you doing your projects this year, myself as a researcher, as a PhD student, as we are part of the people who are developing and deploying machine learning in society. And so it's important for us to think through how we can do this justly. How can we do this so that the current status quo, which is that a lot of socio-technical systems that we have in place, so you can think of this as like healthcare is a broad socio-technical system, college admissions, hiring, a lot of these socio-technical systems, they already disproportionately impact different groups in society. So there are different groups, and you can define these groups, using a variety of criteria. So a good example in healthcare that I looked at, during that I was very aware of during my master's was that Black individuals actually they don't receive kidney organs when they need kidney organ transplants as frequently as white individuals do. And this comes down to, there's an algorithm that was built to help do severity of like kidney disease, and there's a correction in that algorithm that accounts for whether you are Black or not. And so what they've realized over time is that race correction actually results in the doctors and like their risk scores for potentially having very, very severe kidney disease being a lot lower than it is for white people. And so so when that score is factored into, who gets, kidney organs in the transplant list, they end up they're lower on the list, even if they might actually have the same severity of disease. So there are examples like this where it's really important that as designers of these algorithms, we have an important role to play in making sure that these harms are minimized, and that we are auditing for them, and that we're aware of them, and that we make sure that they're not that they don't occur. And I think also while technology broadly construed has a lot of benefits, it's also important as practitioners and individuals who are designing these algorithms, we want all individuals to benefit from the deployment and from the development of this technology. It shouldn't just be the majority of individuals in the world who actually benefit from the development and the deployment of AI and machine learning. So the first thing I'll just talk about is like examples of harms that have like been demonstrated in the research of how like machine learning, without really thinking about the ethics, and without really thinking through the ethics, like the current like state of the art research, actually can have a lot of harm. So the first picture here, for anybody who maybe is familiar with the ethics and like bias in machine learning and AI, might be familiar with this first picture. So what this first picture is from the Gender Shades paper. And this paper, Joy Bolamwini and Tim Jabru, basically what they did is they took a bunch of facial recognition classifiers from like the big companies like Microsoft, IBM, and some startups, and they basically wanted to show what is the accuracy of, like, what is like the error of these models on individuals of different skin tones and different genders. And so what they found is that like darker skinned individuals had a much higher error rate in facial recognition. And what it brought up is that these technologies don't work for everyone. But what it also brought up is that just the use of machine learning and AI for facial recognition and facial recognition in general is just a very harmful practice, and it's one that does lead to a lot of negative impacts, and specifically on minorities in society. And so what this really showed is that using machine learning for facial recognition probably is not a way that we should go, and it even makes sense in many settings to just not have facial recognition at all, given these results. Another one below, which is in the healthcare setting specifically, is let's say we train a model. It's a very large model, and it's a language model, and we want to basically fill in, complete these blank words. So what you'll see in here is that, so let's say we start off with like Caucasian or white. And we're saying like that patient is belligerent and violent, they should be sent to like blank. What we see is that, like, for Caucasian and white individuals, it says like they should be sent to the hospital. But for African or African American individuals, they should be sent to prison. And so or Black, they should be sent to prison. And so there's a very stark contrast between what these models are outputting for the majority of individuals versus what they're outputting for minorities. And this is an example of where it's very important as like developers of this technology and developers of machine learning models and algorithms that we need to be thinking about how these models, when they're deployed, are going to perpetuate existing biases like these, and just contribute to like the disparate impact that these groups experience on a daily basis even more. And then on the right, so this study was actually, so this is like a very simple machine learning algorithm that is used in the US healthcare system to determine like level of care and whether individuals from certain groups should be put into like these high cost but like important extra care programs. And so what they found is that the use of these algorithms is actually a racial bias, such that Black individuals are not put in the program as much, and so there's like less money that's spent on them because there's some correlations that are occurring between like race and and some of the other variables that basically it seems that that they should not be getting, that they should not be put into these programs. And so again, it's the design of these algorithms and thinking through these algorithms that's very important to consider, the ethics and justice and fairness a lot. All right, so now I'm going to talk about privacy and security, which is a different flavor of what I had just talked about. So in privacy and security, we're training all these models on lots of data, and a lot of this data ends up being very personal data. And so the two that I'll focus on are like healthcare examples, mainly because I think healthcare is a domain where the data is so sensitive and it's very personal that you really don't want to be leaking any information about it. And so on the right, on the left here, what you see, this is a New York Times article, and the research was done at the Mayo Clinic. And what they show is that, let's say you have like an MRI of someone's head, you can use a machine learning algorithm and facial recognition software to reconstruct the individual's face, and then you can match that reconstructed face, which is on the bottom row, to real pictures of those individuals. And so you can essentially take a medical image like an MRI, which seems quite privacy preserving in general, because they're very hard to actually distinguish between people, and then use machine learning algorithms and actually re-identify people quite easily. And then similarly on the right, so let's say, so one thing that's quite popular in healthcare is anonymization. So we anonymize data, we remove a bunch of variables, we add some noise to some of these variables, and then we release the data set and we give that data to machine learning practitioners, to train models to predict disease or something. What happens is that these models that are trained on these data sets actually will leak information about these individuals. And so what a malicious user could do, they could take a model that's released publicly, and then they could attack that model in a way such that they can find out which individuals were actually used to train that model. And so it's important. There are different definitions of privacy that have been developed in the cryptography community, in computer science, to basically provide rigorous privacy guarantees. So that's an area of research that I focus on. And that area of research is called differential privacy. Essentially, that provides very rigorous guarantees such that these kinds of attacks that I'm talking about are prevented. But one thing to think about with private security, when we're thinking about the ethics of making things private, is that there's always a trade-off between how much privacy I want and how much utility I get from the data. The more private the data is, the less utility I can get. And that's a fundamental law that's been studied and that's been described and formalized. But the thing is that a lot of the groups, minority groups, are the ones who actually need more privacy, because they don't actually get to trust everyone in society. So a good example of this would be, when Trump was when Trump was president, a lot of Hispanic individuals would not identify their race in hospitals in the U.S. And they wouldn't do that because, there was a fear of ICE coming and finding them if they're undocumented. In those situations where those individuals who are minorities, need a lot of privacy. But what happens is that because there's less of those individuals, then the more privacy that they get, there's a lot less utility for their data. And so there are these ethical concerns when we think about privacy of how do we trade off, needing privacy, but then also needing utility from the data. So this problem has not been solved by any means, and it's one that it can't be solved, but there are ways that ethicists in different areas have to think about, how these trade-offs occur, and the ethics of it. Another area that's interesting in the security side of things is adversarial examples. So what adversarial examples are is, let's say I have this picture of a panda. Let's say I add this basically just noise, what to us as humans looks like noise. I add that noise to the image. It still looks like a panda. So us as humans, we would say that's still a panda. But to a machine learning model, now it looks like a gibbon instead of a panda. And that is very concerning, because let's extrapolate that to self-driving cars. So on the right, let's say we have this really clean stop sign. Looks great. Okay, 99% the model says it's a stop sign. But then we add some noise, we distort it a little bit, and now the model with 80% confidence says it looks like a sports ball. You can imagine those kinds of adversarial examples that show up and that people can create can have significant problems for very safety critical applications like self-driving cars. So these are other ethical questions of how do we deal with adversarial examples in machine learning. So the next thing I'll talk about is like fairness and justice. So one thing that I think is really important for all of us to keep in mind is that AI machine learning is not always the solution. And it's important to recognize like these algorithms they're like part of a much broader socio-technical system that's in place. And sometimes when you introduce these algorithms, you're going to bring more harm than you will good. And so I think as practitioners and as designers of these algorithms, it's important when you receive a problem to understand whether the deployment of this algorithm in this setting will actually be beneficial or whether it's just going to bring more harm than it actually will good. So that's something that's very important, I think, for thinking through like the ethics and the fairness and the justice component of machine learning and AI. The other one that I think is really, really important for all of us to consider is that the individuals that will be affected by the individuals that will be like affected by your algorithms, by the predictions of your algorithms, like deserve to have a say in like throughout the entire development of like the algorithms and like testing the algorithms. Because like at the end of the day, like their lives are the ones that will be changed and that will be affected by the algorithms. And so as developers and researchers, we should be talking to those individuals and we should always be talking with them and making sure that their voices are included throughout the design process. And then it's also like important to collect feedback once an algorithm is deployed on how the algorithm is affecting those communities, especially those that are marginalized, because they're the ones that typically tend to bear the much more negative effects. So, and the other thing that's like a lot more kind of technical in the fairness, in like machine learning and fairness right now is formalizing definitions of fairness. There are several definitions of fairness out there for different settings, and when a huge part of machine learning is the math behind it and trying to formalize, and so there's a lot of work that's been trying to formalize different definitions of fairness, and so. So in medicine, for example, like there's beneficence and non-malfeasance. And so you want to basically like do your best, but don't harm anyone else. And so like, trying to formalize that is like a very important topic in the ethics of AI and machine learning. And sometimes the other thing is you can't formalize, there's a lot of like social determinants and social constructs that we can't formalize well. And so keeping that in mind is something that's, I think, very important when thinking about fairness and bias in machine learning. And the last thing I'll say about fairness and justice is a lot of times we think about like them as static things or static measurements. Like we can measure like the worst performance for some subgroup in your data set with your model, like at that point in time. But these algorithms, once you deploy them and once you've built them, are going to be used most likely over time. And so you want to actually make sure that these algorithms are focusing on like justice and like repairing the disparate impacts that exist or helping to do so, over the long run. So like over years rather than just like at one point in time. So other technical challenges that, we'll see are like explanations. People want to be able to explain the outputs of their models. Value like alignment, which basically just means that we want to ensure that the machine learning algorithms are like, embodying the values that we share as a society. Users can actually steal your model. So there are ways to like steal a model. And that's something that's important. And also just like accountability and responsibility. We want to be able to hold organizations accountable if, their algorithms, are causing harm to society. So I'll just touch on a few more things. So from kind of what I've seen around is that it's honestly quite difficult to do unbiased ethical AI work in industry. The reason I say this is that there's this tension between, generating revenue and the products that these massive technologies that are built at these big corporations are very important and are in a lot of products, but those technologies can often be the ones that are causing harm. So it's very hard for companies to like reconcile between the two objectives. And a good example of this is Timnit Jebru, who does like fantastic ethical AI work. She was a senior research scientist at Google last year, and then she was fired because she wrote a paper that basically talked about the harms of large language models. So basically these very, very large models that are used to do very good language tasks. And she was basically fired because the work showed that like there's a lot of harm from those models. And so it can be hard to do like research and work that just, discusses and cares about like the ethics of AI in industry. But it's all, it can be hard everywhere because you're kind of shining a light on things that are not working. The other thing that I think is good to think about is like think about ethics like the entire pipeline. So when you formulate the problem, think about like who's this going to harm and like what kind of principles you care about when you are formulating the problem. Also, when you collect the data, make sure that you're collecting data in a way that's not going to like harm different marginalized communities, but also will make sure that they're represented. Also, the outcome of the problem, like the label that you're basically trying to predict. Like, if you predict that, it's like going to be helpful, it will be harmful, and who is that helpful for? And then, of course, kind of what I touched on throughout the talk is like algorithm development and like deploying these models. You need to keep those in mind as well. Also, like finally, like collaboration is essential. You should be trying to work with like ethicists, humanitarians, social scientists, like economists, social workers. All of these individuals have like such an important role to play when we're thinking about how to like make sure that things are ethical when we talk about machine learning and AI. And also like legal and policy scholars are very important as well. But yeah, I'll end my talk there. Thank you for listening, and I'll take questions.
Just jumping in here. Thanks a ton, Vinith, for the awesome presentation. Super, super well done, and love the effort that went into the slide deck. Because Vinith had a bit of a shorter presentation, we do have some time for questions. We're not going to start our closing ceremonies just yet. So I really want to encourage everyone to think about like what this presentation made you think about, and ask him some appropriate questions. Like if there's anyone that you can talk to like throughout this cycle of creating your project at QMind about the ethics of it, this is the person to ask. So please, let's get some questions going for Vinith, because I'm sure he's got some really stellar answers for you. Are you able to see the chat, Vinith?
Yeah.
Okay, great.
So
great. Go ahead.
From Tristan, what is the most concerning ethics issue at the moment, in my opinion? It's a good question. Okay, this is like one of them. I think there are a lot, but the one that I think is quite concerning is the use of like people's sensitive attributes. So things like, you know, using race, using biological sex, using gender, using things like age. Like a lot of people just use them without really thinking about what using those features in your algorithm actually means for like the predictions that you're outputting, what kind of biases are like baked into using those variables in your model. And I think it's very, you know, in the research community, it's something that we talk about, but hasn't been well studied. And the thing is, the use of those attributes actually is way broader than like machine learning and AI like as well. Like, you know, it moves beyond it's like in technology and like algorithms in general, like how we use these sensitive attributes. I think it's very important for us as practitioners and designers of these algorithms to really think about how you use them and if you should even use them in the first place. Like it's good to collect them so that we can basically like audit these systems and just see like how they're performing for different subgroups. That's incredibly important. So the collection of them is important, but the use of them is a very different topic that I think is concerning to me, at least. Hopefully that answers your question, Tristan, or it gives you an interesting thing to think about. Okay, Matthew, so is there any way to mitigate the biases from using a more encompassing databases for the AI ML systems? Yeah, this is a good question. Yeah, so I think that's one part of the puzzle is, you know, if your data collection is more robust, or you make sure that it's more representative of the individuals who will be affected by the algorithm. I think that does help with one part of it, but it's still like incredibly that's only one piece of it. Like there are many things that you can do when you design the models or the algorithms that can introduce bias as well. So like something that's been studied recently in the research is, you know, when you compress models. So sometimes you'll take a model, it'll be like too large for like to put in your phone, and so you need to compress it somehow. Compressing the model will actually end up introducing bias, and so you can have a representative data sets, but there are other reasons why bias like is introduced into models, or you know, and even just like sometimes it's not even, sometimes the data set itself, no matter how representative it is, will be biased because maybe the outcome itself that you're predicting is is biased against certain subgroups of individuals. So representation is important in the data set, but there are many things within the data set and the algorithm design that are also important to mitigate bias. Okay, Emily. So what are some of the best ways to educate ourselves with how to approach AI ethically? Yeah, this is a good question. Personally, I think it's like very different for everyone that I talk to. I've honestly been reading a lot of books from like social scientists and humanitarians and social workers, and I do this because I think like it's much better to understand like how like society is functioning and where biases are manifesting in society, like normally, like just without the introduction of algorithms and technology, like how these like large systems like are negatively impacting different marginalized communities. So there's a lot of books that I've been reading to kind of understand in different settings how this happens, and so that's and then from there, what I'll really think about is, and then there's some books as well that like look at this from like the deployment of like algorithms themselves. And so I think like I can send Max a list because I don't have them off the top of my head, and I'm sure he can like disseminate it to you somehow. Just like a list of books that I've read and books that I've had recommended to me on basically just like the introduction of like algorithms and machine learning into like different systems, like hiring, like providing like unemployment insurance and stuff like that, is all interesting things that I think are good to like educate yourself about. But yeah, awesome, that list of Max. Okay, Michael, are you worried about the political implications of deepfake technology becoming increasingly convincing, cheap, accessible? Do you think bad actors could wreak havoc if they really wanted to? Yes, this is definitely a big problem. And the reason I say it's a big problem is because deepfakes are getting very, very good. They're getting very, very good. And the thing that we don't have right now is a way to like distinguish and verify whether an artifact is like synthetic and has been, or whether it's real. And I definitely think bad actors could wreak havoc if they really want to. I think that technology is at a place where they could. And I think now that like there is a lot of research in the security community going on right now to try and figure out like how verification might work in these settings, and how to basically just like find and detect deep fakes. But it definitely is very concerning, and it's something I don't work on myself, but like the lab that I was a part of at Toronto does a lot of this work. Yeah.
Maybe unless anyone else has any other questions, I had one that I think might be applicable to a lot of design team members on QMind, which is for a team starting out a project. Like it could be any one of them. If like for a team who maybe has having trouble identifying where there could be bias or ethical issues in their project and really can't like find any themselves. Do you have any advice for how they could like start identifying them at the beginning?
Yeah, so I guess depends on the data that you have. If you have access to kind of these sensitive like attributes, or like demographic attributes that like you can use to kind of define like marginalized communities that you're aware of, then it's much easier to kind of basically like test your model on like those subsets of the data and see how it's performing to kind of identify whether it's performing poorly. If you don't have access to those attributes, it's like much more difficult. And to be honest, it's very hard to do these like tests and audits for like marginalized communities without access to that. So without access to that, it's actually kind of an open area of research. Is if you don't have access to those variables, like how can you really test and like try and identify these biases? But if you do have access, I would recommend like subsetting the data and partitioning it based on those groups, and then just testing the model once you've trained it, and seeing like how is it performing on these different subgroups. And if it's performing poorly on certain subgroups, then you can kind of see that there is some bias. That's either from the data set itself that was introduced from the model, somewhere in the pipeline, is present.
Awesome. Okay. And I think there's another question in the chat as well.
Oh.
You can see that one.
What was my master's program? Yeah, cool. So I did a master's in computer science. And so at the University of Toronto, it's basically a 2-year program. What I liked about it, so for me, I really like research. So like in the master's program at the University of Toronto for computer science, it's not a course-based master's. So for your master's, you take 4 courses, but you're primarily expected to be doing research. And so for me, that was very interesting and very cool. And I really liked, kind of had the freedom to find the areas that I really am interested in. Like I did not expect to focus on privacy and fairness when I started out in my master's. I thought I would basically be focusing on like disease prediction. But I really liked that I had the freedom and the opportunity to kind of explore my interests and really like find the area of machine learning and research that I really liked. I think it was super beneficial kind of like for now for me to like do my PhD kind of knowing what I really like in the space.
Okay, I don't see any more questions rolling in the chat. So what I can do is I can distribute your contact information if anyone like wants to reach out to you via email. Is that good?
Yep.
Okay.
Sounds
awesome.
Good to me.
So for everyone listening, I'll get Vinith's contact info out. I think I've sent Cooper's contact info, and everyone from DCL, their contact info will all be sent out after Can't Keybind. I don't think we have any more questions, Vinith. So really appreciate the time you spent coming. Oh, never mind. We do have a question.
Oh, yeah. What changes, good or bad, did you notice from going from Queen's to UT to MIT? This is a good question. This is a very good question. I've actually been reflecting on this recently since it's been like my first month in at MIT. Okay. So I think academically, I do think the content that is taught at the schools is very different. I think at the latter two, so at U of T and at MIT, I do think each course goes into a lot more. Like at least in computer science, for me, like I feel like the machine learning course at U of T versus the machine learning course at Queen's, there's a lot more that was taught at the one at Toronto. I think in terms of the culture of the two schools, I think Queen's definitely, and this is a well-known fact, Queen's definitely, I think, like one of the biggest parts of the culture of the social culture is going out, which is a big thing at Queen's. Something that I enjoyed that. Like I really enjoyed that. I think at U of T and MIT, I think so. I've heard for undergrad at MIT till there. At U of T, I think it's less so. For grad, of course, grad school is also very different from undergrad, I think. But I think what I've really enjoyed about the changes is I think going from like Queen's to UT to MIT, I think it's I think just like the depth of like what I've been able to learn. I think like I've learned I think because the faculty I feel at UT and MIT for machine learning at least were like kind of like the leaders of the field. Like I think Queen's hadn't really hired that many machine learning faculty by the time I like. There was basically no one who was doing like core machine learning when I left, and so that was really nice. Also, like living in like a bigger city is kind of nice if you're like into big cities. And then I'm trying to think what else I would say. I think maybe on the less, I think the social aspect is kind of nice about Queens. I think like the fact that it's like not spread out. It's like quite densely packed. Like the community feel at Queens is like probably I think it's the strongest between the three so far. I mean, like granted, I've only been at MIT for a month, so like take that with like a grain of salt. That's like a very short answer to that question. I could go on, but yeah, hopefully that gives you maybe some insight into like how it differs between the three.